Day 2, I'm going to factor the denominator first. So f of x equals -3 times x plus 1 over 2 times x minus 2 times x minus 2. I'm going to rewrite that as -3 times x plus 1 over 2 times x minus 2 squared. Now, we've been talking about this. So that squared means that as I approach the vertical asymptote, my function is going to either go up in both directions as I approach the vertical asymptote, or it's going to go down from both sides as I approach the vertical asymptote. So that's what this squared ends up meaning. I have no removable discontinuities. I have no holes because there's nothing that cancels off from both the numerator and denominator. Nothing makes both of them 0. Horizontal asymptote is going to be, once again, y equals 0. The power on the bottom is bigger than the biggest power on the top. The vertical asymptote is going to be at x equals 2. And as we noted, it's kind of like the quote-unquote bounce back in the polynomial chapter. So it's going to look like one of these. So I have a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 2. Then my x-intercept would be values that only make the numerator equal to 0. So that's at -1, 0. So that would be right about there. And then the y-intercept is what happens when I substitute 0 in for x. So I end up with -3 in the numerator and 8 in the denominator. So I get 0, -3/8. So I want to put that point on the graph as well. So now it basically becomes what's logical. Well, if there's a point here and a point at 0, -3/8, my graph is going to look like that because I can't cross the x-axis anymore. I have no other x-intercepts. Then, since the horizontal asymptote is 0, it reaches some high place and then comes back down and goes toward y equals 0 forever. Since I have a squared in my denominator, that means that the function should end up going both toward -infinity, and my graph should look something like this. That also makes sense if I checked by substituting in large positive values of x and large negative values of x. What I would end up seeing is the limit as x approaches -infinity of f of x equals 0, but I would end up with positive x values or positive f of x values when I had x approaching -infinity. They would be very small, but they would be positive. And the limit as x approaches positive infinity of f of x would also be 0, but it would be approaching, they would be negative f of x values even though it's approaching 0. So it would end up being underneath the axis. As we can see in problem 4, we have an asymptote, a vertical asymptote at x equals -2, and the function goes toward the same side in this problem. That is because we have a squared in the denominator. So as a result, the function goes toward the same, they both go toward -infinity as we approach that asymptote. We also have this x-intercept at -1, and then the function ends up going back toward the line y equals 0. If I look at problem 5, I'm going to factor. So f of x equals 4 times x squared minus 4x minus 21 over -1 times x squared plus 8x plus 15. So this ends up being 4 times x minus 7 times x plus 3 over -1. I can actually move that negative up to the numerator if I want, times x plus 3 times x plus 5. Now I'm going to get rid of some of this because it's also in blue and it makes it a little bit harder to see. So when I look at this, I see that x plus 3 is in both the numerator and denominator. So -3 is going to be where I have a hole. So the x value of -3 is a hole. I'm going to write my simplified version of this function, -4 times x minus 7 over x plus 5. That'll make it easy to determine what value of y my hole is at. So if I substitute in -3, I get -4 times -10, which is 40, over x plus 5. So -3 plus 5 gives me 2. So 40 over 2 is 20. So -3 comma 20 is where my value is. So what I'm going to do is I'm going to scale my graph, and I'm going to scale my graph by 2's. So what that means is if I'm at -3 comma 20, only for the y's, sorry. So my y scale will be by 2's, the x scale will still be by 1's. So at -3 comma 20, there's going to be a hole. The horizontal asymptote is going to be y equals -4. The reason for that is the powers are the same, so I just divide the leading coefficients. 4 divided by -1 is -4. So since my scale is by 2's, I'm going to put something right there. Vertical asymptote is where only the denominator equals 0, so that's x equals -5. So once again, remember that my x scale is by 1's here. So x equals -5 looks like that. X-intercepts are where only the numerator equals 0. So that's at 7 comma 0. And then the y-intercept is what happens when I substitute 0 in for x. So when I substitute 0 in for x, I get 28/5, or you could write that as a decimal if you want, 5.6. So I know that I have a value of the graph at 7, 0. I also have one at 0 comma 5.6. So 0 comma 5.6 is somewhere around there. So here's what I got. Oh, by the way, I drew my horizontal asymptote in the wrong spot. It should be at -4. So hopefully you recognize that while I was making a mistake. So it should be down there. So now all I have to do is match everything up, and it looks something like this. Now, it shouldn't be as wavy as I made it, so that's kind of a poor graph. So this is a little bit better. And then as I'm approaching the other side, it looks kind of like that. Notice that x plus 5 is to the first power. So that means that they're going to go off to opposite sides of the vertical asymptote. Problem 5, we see that the horizontal asymptote approaches -4. So as we go out, we can see from the function that since the powers are the same, we look at the leading coefficients. 4 divided by -1 gives us -4. We also have this intercept at 5.6, and then we have the x-intercept at x equals 7. Problem 6, if I factor the numerator, I end up with x minus 4 times x minus 1 over x minus 4. So notice the x minus 4's cancel. So I end up with f of x equals x minus 1. Well, that kind of looks like a line. It actually is exactly a line. The only difference is at x equals 4, I have a hole. So I have a removable discontinuity at 4 comma 3. So if I substituted 4 into this equation, I would have a hole at 4 comma 3. There is no horizontal asymptote. That is because as I look at this, the power in the numerator is greater than the power in the denominator. If I wanted to, I could call this an oblique asymptote at y equals x minus 1, but that is not anything we'll ever ask you in this course. But basically, this function is exactly this line except for the hole. So there is no vertical asymptote. The x-intercept is what happens um, when the numerator equals 0. So that occurs at 1, comma 0. The y-intercept is at 0, -1. And it straight up just looks like a line that has a slope of 1 and a y-intercept of -1. The only difference is there's a hole at 4, comma 3. When we look at problem 6, it does end up looking like a line, except as we approach 4, notice that the function as a whole, it is undefined at x equals 4. What is the graph like this going to look like? Well, question 7 is following question 6, probably for a reason. So notice that the top is not factorable in any easy way. So I'm going to try and use synthetic division, or I could use long division if I wanted. So 1, 3, -18, -40. So let's take a look. 1 times 5, -5 is -5. -5 times -2 is 10. Then I subtract, I get -8 times -5 is 40. So notice I have 0 remainder. That means that x plus 5 evenly divides this function. So I can factor the numerator to be x plus 5 times x squared minus 2x minus 8, and the denominator remains x plus 5. So notice what will happen is the x plus 5s will cancel out, and f of x will look like x squared minus 2x minus 8. This will look like a parabola with a hole at x equals -5. So this will look like a parabola with a hole at x equals -5. Now, the y value of that hole would be 27 if I substituted it in. So the hole, or the removable discontinuity, is actually at -5, comma 27. This function, as we indicated, is going to look like a parabola because when we did the division, the long division here, or the synthetic division, we would end up getting x plus 5 to be a factor of this. So this ends up being a perfect parabola, with the exception at -5. If I move far enough up to see where -5 is, it is undefined at that value. So -5, comma 27 is a hole.